I'm sorry about that. We had to start a new video to finish off this problem. So as mentioned, you want to isolate one radical. And the radical I chose to isolate was the more complex radical of the square root of 2x plus 1. So the square root of 2x plus 1 is equal to 1 minus the square root of x. Now we're going to raise both sides equal to the index number to eliminate this more complex radical. And we get 2x plus 1 is equal to 1 minus the square root of x times 1 minus the square root of x. So we get 2x plus 1 is equal to 1 minus 2 square root x plus the square root of x squared. And I just noticed this should be plus, so that would yield you that. Sorry about that. So then we simplify and we get 2x plus 1 is equal to 1 plus 2 square root x plus x. So now we still have a radical. So we need to isolate this radical. So to do so, we subtract 1 from both sides and we subtract x from both sides. And we get x is equal to 2 rad x. Still have to get rid of the radical by raising it to the index number. So we get x squared is equal to 4x. Now because we have a quadratic, we know what we're going to do is now move everything over to one side. So we're going to subtract 4x and set it equal to 0 and recognize that we can factor out a GCF. Now we can set each of these factors equal to 0 and solve. And I get x equals 0 and x equals 4. I need to plug both of those into the original equation to check that they're not extraneous solutions. Neither of them are, so we have now solved that equation. Now I would like you to solve this one. The square root of 5x plus 4 minus the square root of x equals 4. So in this one, I'm going to isolate the more complex one, which is the square root of 5x plus 4. And I'm going to do that by adding the square root of x to both sides. So I get the square root of 5x plus 4 is equal to 4 plus the square root of x. Okay? I'm going to raise both sides equal to the index number, and I get 5x plus 4 is equal to 4 plus the square root of x times 4 plus the square root of x. And I'm going to have to FOIL out the right-hand side of my equation. And then I'm going to simplify, and I get 16 plus 8 root x plus x, and that equals 5x plus 4. Now I need to isolate the next radical. So I'm going to subtract 16 from both sides. I'm going to subtract x from both sides, and I get 4x minus 12 equals 8 square root x. Okay, in order to eliminate this radical, we square both sides. Now in this case, we've got 4x minus 12 times 4x minus 12 equals 64x. So we get 16x squared minus 48x minus 48x plus 144 equals 64x. Once again, we have a quadratic, so we're going to subtract 64x to the other side. By doing that, we get 16x squared minus 160x plus 144 equals 0. Now, we see that there's a GCF of 16, so I'm going to factor it out. And luckily for us, this one can be factored into x minus 9 times x minus 1 equals 0. We're going to set each of these factors equal to 0 and solve and get x equals 9 and x equals 1. But what we still have to do is check. So when we check here, we have the square root of 5 times 9 plus 4 minus the square root of 9 equals 1. So I get the square root of 49 minus the square root of 9. So we get 7 minus 3 equals 1. Sorry, equals 4. So does 7 minus 3 equal 4? Sure does. So 9 is a solution. Let's check 1. The square root of 5 times 1 plus 4 plus the square root of 1 equals 4. So the square root of 9 minus the square root of 1 equals 4. Does 3 minus 1 equal 4? No, this is not true. So this is an extraneous solution. Have a great day, guys.